I'm going to attempt to solve a number of problems that are really for some of my students in my pre-calculus class, subject called identities. And really what it is it's a subject that allows you to simplify trigonometric expressions. And that's sometimes very important when you get into higher level mathematics. So what I want to do is present a couple problems, and I'll always be prepared to interrupt these problems and answer whatever questions you have. That said, let's just jump right into it because I have a number of problems to work on. 312-738-1060 is the number you should call with your questions. Let's jump right into it. All right, so I've got this trigonometric expression, cosine pi over 4 minus theta minus cosine pi over 4 plus theta is equal to radical 2 sine theta. And the idea of this subject matter is some people look at this right here. They look at this and the first thing that they say is, oh, this gives me a headache. That's what they say. But this is meant to give you a headache. It's a trigonometric expression that looks like a mouthful. It looks very, very difficult to work with. But the idea of an identity is it forces students to simplify all of this down to something that looks much more manageable. When you get into higher level mathematics, this is much more manageable than this. And this subject, what it requires, a lot of identity problems require an understanding of some truths that have already been established. And what I'll do is I'll put a truth that you would have to already know prior to beginning this problem. I'll write it right off to the side here. Before you even began this problem, what you would have to know is that the cosine, let's just write cosine of u plus or minus v is equal to the cosine of u cosine of v minus plus, I'm running out of room here, the sine of u sine of v. So really, this is all one line here. This is all one line, but I ran out of space here. So you would have to know this coming into the problem. The cosine of u plus v is equal to the cosine of u cosine of v minus plus sine of u sine of v. Now what this represents is one identity. Oh, actually, I'm sorry. This represents two different identities. If you have the cosine of u plus v, if you have a u plus v, well, then you take the cosine of u cosine of v minus. All right? So this plus, if you're adding, you end up subtracting. Here, if you end up subtracting cosine of u minus v, well, then you take the cosine u cosine v plus sine u sine v. So this one expression actually represents two different identities. The reason why they write it like this is so they don't have to write two different statements. All right? So that said, what you're going to have to be able to see here is that you have the cosine of something minus something. This is a cosine of pi over 4 minus theta. So now when you have the cosine of something minus something, you're going to take cosine u cosine v plus. All right, so we're going to apply this to this expression right here. All right, so we have the cosine of u minus v. If we have the cosine of u minus v, we're going to take the cosine u cosine v plus. Let's do that right here. So we have the cosine, you can't see it, sorry. We have the cosine of pi over 4 cosine, cosine pi over 4 cosine theta. All right, so you have cosine pi over 4 cosine theta, cosine u cosine v plus. All right, when you're subtracting, you have to add. So we're going to add sine u sine v. So we're going to add sine pi over 4 sine of theta. All right, so this cosine u minus v forces you to take cosine u cosine v plus. And then we had sine u sine v. Now what I want you to be able to see is we still have not addressed that yet. We have not addressed this yet. So let's say minus. Let's say minus. We have to put all this in parentheses. All right, so let's erase this line here, get this out of the way. Now we have cosine u plus v. Cosine u plus v. When you have cosine u plus v, you have to take cosine u, cosine v minus. All right, so let's do that. All right, so we have cosine pi over 4, cosine theta. Because we're adding here, now we're going to say minus sine u sine v. Sine pi over 4, sine pi over 4, sine of theta. And all of this, once we simplify this down, should be equal to radical 2 sine theta. And that's what we are in the process of making sure of. It's an identity. What I teach my students is not to touch one side of the equal sign. Try to ensure that this left side, if simplified down, equals that. All right, let's keep going. So now what you have is you have the cosine of pi over 4. And if you are understanding this video, if you are understanding this program right now, you should know what the cosine of pi over 4 is. You go to your special triangle. You have a 45, 45, 90. Pi over 4 is the radian equivalent to 45 degrees. The ratios on the triangle, 1, 1, radical 2. So the cosine, by definition, is the adjacent to the 45 over the hypotenuse. So the cosine of pi over 4, which is the same thing as 45, is 1 over radical 2, times the cosine of theta plus the sine of 45, the sine of pi over 4. The sine of pi over 4, it's opposite over adjacent. Opposite over hypotenuse. That too is 1 over radical 2 times the sine of theta. All right, so we have minus the cosine of pi over 4. We've already said that's 1 over radical 2 times the cosine of theta. Bring that down, cosine theta, minus the sine of pi over 4. That too is 1 over radical 2 times the sine of theta. All right, so now what you're going to do is you're going to distribute that negative. You end up with 1 over radical 2 cosine theta plus 1 over radical 2 sine theta. You distribute that negative. You get minus 1 over radical 2 cosine. I'm sorry, I didn't put the... I'm sorry, forgive me. That's 1 over radical 2 cosine theta. Sorry about that. And then you distribute the negative. You end up with... I didn't put the theta here. I'm sorry about that. Plus 1 over radical 2 sine theta. All right. Now what I'd like you to observe is there's cancellation here. 1 over radical 2 cosine minus 1 over radical 2 cosine. There's cancellation there. You end up with, these are like terms, you end up with 2 over radical 2 sine theta. All right. And this simplifies to, if you multiply this by 1, you multiply by radical 2 over radical 2, multiply by radical 2 over radical 2, you end up with 2 radical 2 over 2 sine theta. And this simplifies to radical 2 sine theta, which is the same thing as what this original problem, the original problem said that all of this should be equal to radical 2 sine theta. And that's what we ended up with radical 2 sine theta. That's the proof that you, that's the proof that this is correct. All right. So the thing we want you to be able to see is in a higher level math class, this is very, very difficult to work with. Very, very difficult to work with. But if you're able to simplify it down to something more manageable, whatever it is that you would have to do with this is much easier when it's in this form versus this up here.